So let's start intersections of solids. The first question I'll be doing is this one over here. It's actually intersection between a hexagonal prism and a triangular prism. First of all, let me explain you what prisms are. Okay, so check this out here. All of these are prisms. Okay, there are two different type of solids. There are right solids and there are oblique solids. If the height of the solid is perpendicular to its base, we call it the right solid. If the height is inclined to its base, we call it oblique solid. And there is another categorization, we call it regular and irregular. If all the base sides, look at this one here, are the sides of the base equals to each other, we call it regular. If they're not equal, for example, this one here, in a rectangular one, the sides are not equal. So you can see that that's an irregular one, okay? And there is another one that we have to know is what is the difference between prism and a pyramid? Prism is something when we see the lateral edges, you see these lateral edges, the height ones, they are parallel to each other. Even if the solid was inclined like oblique solid, even then they will be parallel to each other for a prism, okay? But for a pyramid, they are not parallel to each other. Look at these. The lateral edges are not parallel to each other. They are merging towards a common point. That's a pyramid. If the sides are equal to each other, we call it regular. If the vertex is in the middle of the base, we call it right. So all of these are regular pyramids, and they're also right pyramids because the vertex is in the middle of the base, okay? And look at these ones here. The cylinder is actually a prism. It's a prism with no sides over there because you can see the lateral edges, the vertical edges, they are parallel to each other. And a cone is actually a pyramid with no edges over there. But you can see the lateral edges on the side. I'm talking about the base edges were not there, okay? But the lateral edges are there. So in case of a sphere, it doesn't fall in any category, okay? It's a separate thing. If you cut a solid parallel to its base, we call it frustum. If you cut a solid inclined to its base, we call it truncation, okay? So that's what it is. Now let's go back to the question. Now let's start this question. In this question, you can see that the vertical solid is the hexagonal prism and the inclined solid is a triangular prism. They are both right type, means their length is perpendicular to their base, okay? And the smaller in cross section is a triangular prism over here, okay? So first thing that I'm gonna do, I'm gonna name the sides of the triangular prism, okay? So I'm gonna go with this and say this is edge 1, this is 2, and that is 3, okay? And in the front view, if I want to project 1, 2, 3 in the front over there, 1 minute. Construction lines, let's see. Yeah. So if I project this to the front and this to the front, I can see where edge 1, 2, 3 is in the front, okay? So what I'm gonna do, I'm gonna name that now. So this is edge 1 and that is edge 2 and 3. You can see that, okay? Now you can see that the top view is already complete. Edge number 1 is intersecting the hexagonal prism at this point. Edge number 3 is intersecting at this point, and edge number 2 is intersecting at that point. Let's name those points, okay? So I'm going to say this is 3 prime. Intersections are called primes, okay? And this is 1 prime, and this is 2 prime, okay? All we have to do is find out these prime points in the front view. To find out those prime points, it's not that easy, okay? Finding out these points are not a problem, but in between points are crazy, okay? So I'm going to show it to you how it works. So I'll project 1 prime down and I'll project edge 1 this way. They intersected. The intersection point is called 1 prime, okay? Then I'll do it for edge number 2. This. Okay, that's going to be 2 prime. And then I'm going to do it for 3. No need to draw it for 3 because it's the same one as 2, okay? You can see that they are both at the same point. So next thing I'm going to do is I'm going to name these points. So this point and this point, let's name them. Let's call them 1 prime, and this is 2 and 3 prime. Okay, now starts the hard part. Okay, the next thing you're going to notice in the drawing is that 1 prime and 2 prime are not on the same faces of a hexagon. 2 prime is on this face and 1 prime is on that face. So what you have to do is you have to find out that in between point. Before doing that, I will recommend you doing one more thing. You're going to say this thing here. You're going to say 1 prime is connected to 2 prime with a point in between. So I'm going to call that point A prime. And let's say that's 2 prime. If you go from 2 prime, look at this. If you go from 1 prime to 2 prime, you have to go through that corner. So it's 1 point, okay? But if you want to go from 2 prime to 3 prime, you have to go through 2 corners. I'm going to show to you in 3D what it means, okay? 2 prime is passing through 2 points, okay? So B prime and C prime and then connected to 3 prime. And going from 3 prime to 1 prime, you just have to pass through one corner, so it has to be D prime. So D prime and 1 prime. Let me show you where these points are, okay? Just remember the sequence 1A2, BC, 3D1, okay? So if you open up the SolidWorks 3D part over here, which is this, you can see this is 1 prime, that point over there. And this is A prime, and this is 2 prime. You can see in the top view that where they are. They are here, here, and here. Is it? And then going from 2 prime to 3 prime in the back over there, you have to go through the corners again. I told you 2 prime, C prime. It's actually not C, B, because we used A so far, is it? So this is going to be B. So it's going to be 2, B, C, and 3 prime. And then going from 3 prime to 1 prime, you have to again go through that corner. And that corner is D prime. Why do I name it again? Because the previous point was lower and the new point is higher. There, you can see that, okay? So I'm gonna go back to the drawing, and here we go, the solution starts, okay? So I'm gonna say this point is A prime. My job is to find A prime in the front view, okay? So I'm gonna do this thing here. Here, that's gonna be A, okay? And then you can see A is between 1 and 2, okay? So when you project A prime to this side, you're going to make sure it's intersect line 1, 2, okay? And then project it down until the front. And from this view, you're going to make a line parallel to the length of the solid, that, okay? And then you're going to project this corner down, which is going to give you point A prime there. So that's point A prime. Let's mark it and name it. Yeah, now it's good. So I will say that is A prime, because this edge is what? This point. This point here, it's actually A, is it? And that one was A also. So now let's first find B prime, C prime, D prime, all of them, okay? So I'll do it one shot without talking. So here, 2, this is B prime first. Let's name this. The line is construction. change it to text. Okay, so this is B prime, C prime, and D prime. When you project them, B prime goes on the back edge. Why it is on the back edge? Because 2 to 3 is passing through B and C. So when you project this B prime, you're going to project it to the back edge. And so is for C. C is going to be there in the back, and D is going to be here at this point. So when I name them here, so 1 minute, let me change the layer. So this point is B, and that is C, and that is D. Once I get these points, I'm going to project them to the front view. D and A are in the same line. So this is point D also, okay? So I'm going to say this is A and D. And so is going to be A prime and D prime. Okay. So next thing, now let's project point B and C to the front view. These points over here, they are here because you can see that they are on edge 2 and 3, is it? And edge 2 and 3 is vertical kind of thing. It's perpendicular to the folding line. So all of these points are going to be at the same point in the front over here. So this point is going to be 2, 3 and C, BC. Not CD, BC, because AD is already done. Okay. And let's find C prime and B prime in the front view. C prime and B prime in the front view, they are going to be here. 1 minute. So this until this corner, and from the front view BC there. So they intersect at this point, is it? Let's name that thing. This is going to be B prime and C prime. Okay. We already have A prime and D prime. I can review it for you. Look, A prime was here. If you projected A to this point, projected down, that was A, and a line from A parallel to the length of the solid was this line, and then you projected A prime from the top view, which intersected there. Okay, so that is A prime. And for D prime also, because D is on edge 3, 1, because you can see the naming here, okay? So if you project D prime to this edge and then project it here, it's at the same location as A. You can see that, is it? And then you make a line parallel to the length of the solid and then project D prime to it, okay? Which is gonna give you A prime, D prime, B prime, and C prime, all of them, okay? Now, once you got all the points, you have to join them with solid and hidden lines. How do you know something is solid? When you connect 1 prime with 2 prime, it is in the front of this hexagonal face. So anything on this line, this line, this line, and that line will be solid. So if you go from 1 prime to 2 prime and then back to 3 prime, but it's passing through the corners, is it? So let's count the points in between also. So 1 prime, A prime, 2 prime is solid. 2 prime, B prime, C prime is solid. C to 3 prime is what? Hidden, because it's in the back face. And 3 prime to D prime and is again hidden. 3 prime to D prime is again hidden. So 1 prime, 2 prime. It's not 2 prime, actually A prime. 1 prime, A prime, 2 prime, and then going from 2 to B prime, and then to C prime, which is going towards the page, and then there will be a hidden line from C prime to 3 prime, that's a hidden line, but it's overlapping with the solid line, so you don't draw anything. Now from 3 prime, you draw a line again that will be hidden to D prime. I told you in the top view, okay? So everything is done. That's the complete intersection of the solid. Let me show you the 3D. Everything is going to make sense over there. So this, okay? Let me show it to you in hidden. Check this out. So what we just did, we connected 1 prime with 2 prime passing through A prime, which is solid. And then from 2 prime to this point and that point, which is B prime and C prime, which is also solid, but C prime to 3 prime is hidden. Okay, it's in the back. And then from this point to that point, it was hidden again. And this will go solid or hidden, doesn't matter, because it's overlapping with this. Actually, it is hidden because the visibility is checked based on both of the solids. Anything until this point will be solid. Anything after this point will be hidden, okay? Because this solid is going to make it hidden for that side. Only for this side it is solid. Let me show it to you in color. You're going to see it. Anything on this face will be solid. And anything on that face will be what? Hidden. You can see that, okay? So that's why when we were naming them, we named it this way. 1 minute. We said that 1 prime to A prime is solid, A prime to 2 prime is solid, then to B prime is solid again. And from B prime to C prime, it doesn't matter because it will be a dot, okay? Because B prime to C prime will be a dot in the front view, is it? It doesn't matter. And from C prime to 3 prime, it will be hidden, not solid. It will be hidden. It's in the back over there. I told you, okay? And then from 3 prime to D prime is hidden again. And D prime to 1 prime is hidden again because it's on back of this line, is it? So that's the complete solid. And that's what we have to do. If the solid was not properly centered, you will be able to see the hidden lines in the front because they will not be overlapping with the solid lines. This is end of this question. In the next video, I'm going to do the next question.